Today, we are going to build an AI voice assistant using Twilio Voice and Google Gemini. We are going to use Twilio's ConversationRelay, which is a high-performance, low-latency way to connect your calls to an AI via WebSockets. I'm Rishabh, and in this video, we are going to set up our environment, write our FastAPI server, and see Gemini in action on a live phone call. Let's get to it. Now here's how it works. When a user calls your Twilio number, Twilio hits our FastAPI server for TwiML instructions. Our server responds with a connect verb, telling Twilio to open a WebSocket connection. As the user speaks, Twilio streams the transcript to our server, which we then pass on to Gemini. Gemini generates a response, and we stream it back to Twilio for the final text-to-speech output. To follow along, you'll need a Twilio account, where you'll be grabbing a phone number in the Twilio console. Today, I'll be using this number. Then, you'll also need a Gemini API key. You can head over to AI Studio to generate your key, and ngrok or any other tunneling service. This will be used to expose our local server to the internet. Let's start by setting up our directory with a virtual environment and then activating the said virtual environment to install our dependencies. Now you'll be needing Google Gen AI, so this is for talking to Gemini API, python.env, this is for managing environment variables, FastAPI, WebSockets, and UVCon. Now this might take a few seconds to install all of them. Once those are installed, let's open and create a main.py file in a code editor. I'll be using VS Code. Before we dive into the demo, let's walk through the code so you understand exactly what's happening under the hood, because this is where the magic happens. To get us started, I've created two files, main.py and .env. Let's start at the top of main.py. We are importing everything we need to build this AI assistant. We are using FastAPI for our web server. If you couldn't tell by the name, it's incredibly fast, and it also handles WebSockets beautifully. The Google Gen AI library gives us access to Gemini, and we load our API keys from the .env file for security. Now let's add some configuration. Here I have defined few configuration as environment variables, so port, domain, and the WebSocket URL. This we'll use later for our WebSocket connection. And the important one is the welcome greeting and system prompt. The system prompt is crucial as it shapes how Gemini behaves. Notice we are telling it to spell out numbers. That's because Twilio's text-to-speech engine will read 2024 as 20,024 if we don't format it correctly. These little details make the conversation sound much more natural. Now let's move on to the Gemini API initialization. So here we are grabbing the Google API key from our .env file, and also if it's not present, to raise an error. Then we are initializing the Gemini client with the new SDK. Now we are also creating a sessions dictionary. This dictionary is really important as it stores a separate conversation history for each caller using their unique Call SID or SID. This means if two people call at the same time, each gets their own independent conversation with the AI. No crosstalk. Now it's a good time to initialize our FastAPI app. Now let's also create a Gemini response function, which will take two arguments, the chat session and user prompt. We'll be using this function later to get a response from Gemini, again based on those two arguments. Now here's the first endpoint that Twilio will hit as soon as someone calls your number, which will be the /TwiML. So when Twilio receives a call, it makes a post request to /TwiML. We respond with TwiML, which stands for Twilio Markup Language, which is just XML that tells Twilio what to do. The conversation relay verb is the star here. It tells Twilio three things. First, open a WebSocket connection to our WS URL or the WS endpoint. Second, handle all the speech-to-text conversion automatically. And third is to play this welcome greeting when the call connects. So remember, we set the welcome greeting up on the top under configuration. This is where that will be used. Now, Conversation Relay is doing so much heavy lifting for us, from transcription, streaming, text-to-speech, all in one simple XML tag. Now here's where things get real time. The WebSocket endpoint manages bidirectional conversation between Twilio and Gemini. So I have named it appropriately as /ws. Here, first we accept the WebSocket connection. Twilio will send us JSON messages in real time as the user speaks. Now when the call starts, Twilio sends up a setup event. We grab the Call SID, which is unique to that conversation, and create a new Gemini chat session using the chats.create method. You can also see for the model, we are using the Gemini 3 Flash preview, and we are also passing in the system prompt, which we set up earlier. This is the critical part. When Twilio transcribed the user's speech, it sends a prompt event with the text. We pull out the voice prompt, send it to Gemini using our chat session, and get the AI's response. Congrats! They're officially in the talking stage. Notice we are using chat session and passing it to our Gemini response function. This is key as it maintains conversation context. Gemini can reference things that were said earlier in the call. No more amnesia-afflicted robots. Then we send AI's text response back through WebSocket. Twilio receives this, converts it to speech using its built-in TTS engine, and plays it to the caller. The entire round trip, the speech-to-text, AI processing, text-to-speech, happens in a few seconds. Finally, when the call ends or something goes wrong, we clean up the session. This prevents memory leaks if you're handling hundreds of calls. Also, we have some interruption handling as well. So to recap the flow, a user calls, Twilio hits the /TwiML. TwiML opens WebSocket, the user speaks, and Twilio transcribes. We transform that into JSON, send that JSON to Gemini, get a response, send the response back as JSON, and Twilio speaks to the user seamlessly. This loop is happening constantly for the entire call. Now that we understand the code, let's see it in action. All right, to bring this to life, we have got our code ready, so let's save that Python file, and let's run through the setup step by step. Open up a new terminal window to start a tunnel. So I'll be using ngrok today, and the port that I want to open up to the internet is 8080. Now this will give you your publicly accessible URL, exposing your port 8080. So grab this ngrok URL. Coming back to our .env file, let's paste this in the ngrok URL value. Now you don't need the HTTPS, so remove that. You just need the domain itself. For the Google API key, I'll set this value off screen for obvious security reasons. After setting your Google API key, fire up another terminal window. Make sure it has the virtual environment activated and the dependencies installed. We'll start our FastAPI server by using python main.py command. You should see a message saying the server is running on port 8080. Perfect. This is my favorite port. Our backend is now live and ready to handle calls. Now here, you'll need to set up your Twilio phone number. So let's head over to our Twilio console. Now here, you can click on your number under phone numbers and then click on the configure tab. You'll see a setting for voice configuration. And you can see when a call comes in, you want it to be a webhook. Make sure the HTTP method is set to post. Here you'll paste your ngrok URL with the /TwiML. So let's go to our ngrok terminal window, copy this, go back to our Twilio console, paste that in there, and then add /TwiML at the end. Save this as the configuration. This means Twilio will now route incoming calls to our FastAPI server. Now comes the moment of truth. I'll be using the Twilio dev phone today, and I'll dial the Twilio number. Now for better visibility, I've split the screen between my terminal and the Twilio dev phone here. Now let's call our Twilio number.
Hi, I am a voice assistant powered by Twilio and Google Gemini. Ask me anything.
So I'm going to mute here, but as you saw, the welcome greeting came through. Now let me ask it something. Hey Gemini, what's the biggest or largest planet in our solar system?
The biggest planet in our solar system is Jupiter.
Anyway.
It is a massive gas giant, and to give you an idea of its size, about 1,300 Earths could fit inside it. It is also more than twice as massive as all the other planets in our solar system combined.
Great job, Gemini. Notice how smooth that was? Let's try up a follow-up question. Gemini, give me a fun fact about Jupiter.
Here's a cool one for you. Jupiter has the shortest day of all the planets in our solar system. Even though it is massive, it rotates so quickly that a single day lasts only about 10 hours. Because it spins so fast, the planet actually bulges at its equator and is slightly flattened at its poles.
What's really cool here is that Gemini maintains the conversation context. You can see in the terminal that each message is being tracked in the sessions dictionary. So the AI remembers what we have been talking about. And did you notice the latency? It's incredibly low. From the moment I stop speaking to when Gemini responds, it's just a couple of seconds. That's the power of Twilio's Conversation Relay and Gemini 3 Flash working together. Dream team right here. You also saw when we hang up, the WebSocket disconnects automatically and the session is cleaned up once again. And that's it. You have just built a real-time voice AI assistant. From here, you can customize the voice using providers like 11 Labs or add tool calling to make your assistant even more powerful. You can find the full source code in the GitHub repo linked in the description. Don't forget to like, subscribe, and hit that notification bell for more Twilio Devs content. We'll see you in the next one.